Hello, everyone. Welcome. I'm newtmechanist, and today we're continuing our game dev project. We're going to see if we can finish up generation of the flow maps, the way that enemies move around the rooms. We'll see. We'll see. Hey there, Key. Welcome. Checking in with the kitties. We have Molly and Ember there on the side. Ember passing over, trying to walk onto my lap, being indecisive. Now don't rub your chin on that. Come here. Come here. Yeah. Uh-huh. Come here. That's... We have Sammy and Sherbet over there in the play area. Sherbet really likes the TV screen. Mason and Sky are napping. Yeah, hello. Ember has hopped over on the canvas to get ear scratches. If she's not comfy on my shoulder, sometimes she will hop over there and entice me to give her pets that way. But yeah. So last time we got the basic flow map going, and I changed this to be flow generation. Seemed more appropriate, more accurate at least. Accurate to what we're doing with it. Whoop. Well, we broke something. Which implies that this thing is not active. And in our services, we are adding it. So let's see where that fails again. Get flow to center is not doing anything. An interface, so we have our flow generator, our get flow to center, right here. Currently null. If it is equal to null, I'm going to check if the file exists. Going to load it from the file. We got nothing out of that. I thought this was working. Well, let's check. Something has gone wrong. You know, as is tradition. Average day encoding, indeed. It exists. All right, we are going to delete it. We're going to change that to is null, does not exist. We are going to create it. And we have an image. We are repeatedly asking it because there is a movement type for that. We'll have to verify that these are not storing data they don't need to. End that. Put a breakpoint here. Gonna run it again. The file exists. We try to retrieve it. It is now null. Okay. Load from file doesn't like that. Let's... First time we run it, it's going to get created. Just so. We let that run. We end the program. We come back in here again. The file does exist. We load it from file. Okay, it wants the actual extension. Is there a way to load it from file that doesn't care about that? Let's do a quick check, shall we? Can I set the file type? Use the file access class. No, it's not what we want. Well, nothing for it. Oh, there's probably something for it, but I don't care. Bloop. And once again, for those that haven't seen it, this is our flow file. We are using a high-def image, essentially, to record vectors to the center. We're using an image file because it gives us some extra floats for metadata if we end up needing them. But we are using the red and the green of these to represent horizontal and vertical direction in the vector, which is why you have this black segment, because in those cases both numbers are negative up and left, which results in no displayable color. But that data is still there and is technically interpretable by image generation logic. We aren't using it for that. Okay, and we want, there's an inbounds. Okay, so I believe this was where about where we were last time, where we are defining what it would look like, and then we will have to define where to look for it in order to retrieve it. Like, does this exist? Yeah. the floor flow. It's the flow extension. Flow file is flow plus floor extension. Flow extension. Okay, so we're going to check for the file, which is we're going to look for the texture key plus that. Check for it. If it exists, we load it from file. Otherwise, we create that flow. And this is where we are doing this. In theory, we can load this into a shader and handle this for us. And we probably will. We will execute the shader. But we need a way to wait for it to be done. Actually, we don't. Since this is during loading, we can just say, gimme result. So we won't have to check inbounds here in the same way. And we should be able to check our width in this. Game and not entities. Collision. In the compute shader, check our collision here. Or which one we're looking at. So we will need a way to define it. We could load it as an image shader, create that, and then display it, but I don't know if that's actually going to give us the data that we want. But that could be a way to go about it, is to attach a material to it and see what the result is. Create a false scene that isn't actually visible. Now, or where all the textures are off screen so that they are loaded by default. And that could work because we don't care about any other data for this one. And it would let us prefabricate all of that when we're ready. Let me check something again. I don't really want to do it that way. Don't want that. We should just run another code shader, I think, or compute shader. Let's find out. To rename that to shaders. Run this and make sure. Should be able to see Mason on this. That brief surge where we generate 10,000 enemies. And again, 10,000 enemies, we're still getting over 20 frames per second. We could still see a collision happen there. Okay, we'll do an intermediate. There's technically a little bit of extra in that, but yeah. Yo. Well, that explains why Sammy is here. I'm sorry, did I startle you? Sammy is out here on the table because Sky is in her spot. Says, no, you startled me. I'm going to go over here to my shelf spot. Okay. We have this. Really should change more of that. I might have to move the shaders out there to somewhere more generic and kind of subfolder them off of that, so I have a nice uniform way to get to the shader folders, and then I can just say, oh, you know, this is the parent folder, and then, well, this is the parent folder. So I can say, you know, collision inside the shaders, and that gets me the compute shader. But anyway, so we need to make another compute shader for flow generation. So we'll add a folder for shaders. We'll add this will be that. Then we're going to use some of this information from the prior one. We will open it up over here. To have our entry point all the way down here. Hey there, Laura. Was watching some clips of Helldivers recently. The cyborgs are intimidating suckers. Might have to try it out at least once. Okay, so we want a texture passed in. And that texture we're going to iterate on. So let's see. Just looking up a result. Sampler. tutorials. I want to just access it. I want to set it. Not as a material. And I am looking at something in web browser and just trying not to blind everybody. Pass that in. Collision manager. Creating uniforms, and in the existing one, do not reference them as uniforms, though. We're setting them up as buffers. That should technically be okay. We want it to be a buffer because we can get more space out of it. I think should be okay. Yeah, we're looking up stuff. Sorry if there's nothing to look at. Cats. Buffers and storage buffers, yeah. Godot documentation, stable version. The data. And document, blah, 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 blah. Okay, let's see. Let's see if we can parse this out. In a start step that we would be using. Given that this one is universal, we should be able to do it in our creation step here. What do we want to do? We need the same logic that we use here to create the initial shader. So we get a rendering device. We aren't well, yeah, we'll load it from the shader. Yeah. Then we are going to create buffers. spans. Hello, Ember. Come on. We would need the data as bytes. Start. To an image format. That, not that. I think we can do get data and get data size here. Then we have to have we could just do this with the sampler though and use the default logic. Pipeline. What do we have? Or I'm using image 2D or sampler 2D type. Set a shader parameter. Hey there, King Tag. We're looking up some documentation right now. Suppose I should just switch to this whenever I do this anyway, so at least you can see cats. We are setting up another compute shader, and I'm deciding how to set this up. I think we might be able to be a buffer. That. You have to treat it as a texture in there. I don't know. I am using Godot. I think we can still do it this way, though. So we need to set it up as a uniform sampler. We're going to pass it in by its actual handle, set shader parameter by that. That doesn't line up with how you set it, though. Do. We also need our output. There's the output texture. We can input, we can set it appropriately. That should be okay. And we're going to, we want an input and an output to it. we are going to have an output texture. So what we're doing right now, King Tag, is we're creating a sort of movement flow for each of the entity, the rooms that will be in the game. As far as enemies are concerned, as far as enemies are concerned, they're always moving towards the player most of the time. There will be types that don't, but they'll have some specific logic. For the ones that are moving towards the player, that basic movement is easy. You know, this is where the player is. This is the direction we're moving to. Little wasteful to have to convert it to normalize the vector constantly for the type of calculation we're doing. But ultimately straightforward. It's ultimately just simple math calculations going on. But when you're dealing with things like walls, it gets more complex than that, because if they just try to move straight towards the player, that's a problem. And we can't use physics bodies because we're dealing with too many things for that to be viable. We're just binding it. Where is... Where is my official documentation? Not that. So when I'm doing like Google searches and documentation, I'm generally just going to show pictures of the cats. I do encourage people to look up documentation. I just don't need to, like, you know, white mode flashbang everybody every time I search for something. Oh, so I need to set up the uniform in it. Right now, we're setting up storage buffers. Let's just paste through that RD uniform. Not shader language. Should be able to find it in here somewhere. We're setting the shader parameter, which is going to be a uniform. So it should be a uniform sampler 2D that we're passing in. And then be by its name, so blue value. Ow. Ah. Do some wrist rotations, see if I can get that to stop. Where are we putting that? We want to pass it in, so we need to see where they're defining uniform sampler 2D texture. Okay, we're just going to roll with that. Hopefully we won't run into the size limitations. Get the binding there. 2D. Let's grab you. Get our floor texture, and then we are going to get our flow texture out. then we're going to pass both of those in as uniforms once we get the shader set up, which we are going to have to do using our set shader parameter once we've got our... There's got to be a better way to go about that. But we're just doing shader parameter. Oh. Create that. Are we just setting the shader parameter again? We should have the information that we need. We're setting it up. We have layout uniform image 2Ds. Yeah, okay. We're going to use these. And we will have to find the sample for where we are actually passing them in. This is nicer. This is nicer. Because we want to set that parameter on what they are. I think it's RGBA 8 that our stuff is going to be in. I don't know if it's going to be 16F, but we're going to try RGBA-H because that's what we're going to be outputting. Just take these for now. They're similar in name. H, RGBA 8. All right, Godot, what do you think? Might be out of date as far as how it's set up. Might need to use sampler. This could be out of date, but sampler might be specific to non-computes. Is it? I think we're doing half, so it's like 8F. Okay. Doesn't like either of those. Okay, we need more of that. Just a moment. Format tags. Compute shader. Channel 32-bit floating format. Will that work? Can we use... We should be able to use EXRs in it. They're not 32-bit floating, though. Half float, 16F. Okay. Back we go. 16. Okay. Input and output texture. Let's make sure we're using everything we can here. Not buffer, but can I do restrict read only in here? Okay, good, good, good. Will this all work? Let's find out. So what we're doing is we're going to set up a pass for each time we do this. We're either going to just load it from file, or we are going to create it here. And this will not be fast. The only time they should be getting created is the first time, like when I am building the game. I will make it, and then I will, include the actual files. Or the first time a mod is loaded, it would need to do this. We're making a Vampire Survivor style game, King Tag. This won't be a perfect showing of how it will operate, but this is... the game runs very slowly because there shouldn't be 10,000 enemies. But we're still getting 20 frames per second, and maybe we just... it's taking a little over... We're getting like 1/3 speed as far as world simulation ticks while this is happening. So this is not something that should actually happen in the game. But we're doing performance testing for it. That's why I'm using C#, is I am culling down or squeezing every bit of performance I can. So our physics is pure Godot physics server stuff, paired with... Well, actually, no, it's not physics server stuff. This is our collision. This is a compute shader that we run to determine collisions. So once a physics frame, we ping the graphics card, or GPU, to determine what hits what. So in theory, we're going to go over float texture for each part of our layout here. We will need to derive this from the size of the texture for each iteration. We'll try to break it up as much as we can. There will likely be passes that we don't need to do. This would be so much easier if we could extract the display information from a regular shader, but it is what it is. We're going to need an example of actually operating on it. We can get from image load a particular coordinate. But our local size is not going to be enough for this. We're going to need to have another uniform that is going to be our image size so that we can calculate the breakdown using our workgroup size. As well as our local size. I don't want to do it all local, that's a waste. So we would need to determine number of pixels per block that we need to do and pass that in as a uniform as well. And we would iterate over it in those segments. So something like... yeah, at the moment, dark mode. Normally I do like a incognito search so it doesn't try to serve me weird ads. Okay, so we're not using Sampler 2D because this isn't a regular image shader that we're using. So our global invocation is going to be what we're doing for each part. Really like to see what they're doing with local invocation. That's kind of weird. Okay, that's just example. So again, for the potential failure points of vibe coding, they have set up local invocation. Each time a global invocation happens, this many local invocations happen. So 64 local invocations happen. This code only uses global invocations, which means this main function right here that they have in their example is run 64 times, in which it does the exact same thing. Is this actually like AI generated code? Maybe, but it has the hallmark of why would you do this? Why would this not be 111? Because this doesn't use the L underscore invocations, or the what is it called? Size. GL underscore local invocation ID. It doesn't use them, which creates a scenario where somebody who is looking at that, potentially a scraping program going through source either public repos or just searching for internet samples, could see this, and it becomes part of training data. That this is something that should be at the top of a shader. And if enough things like this happen, this becomes something that just gets inserted into the top. It's part of the reason that a lot of platforms need extra hard-coded guardrails as far as include statements, as far as packages that get loaded in. Because that's not with purpose, that is by shape. Those packages are frequently at the top of of code that does this kind of thing. But they could be wrong, they could be extraneous, all kinds of stuff. And if we're getting down to code like this, GPU and C++ kind of code, that can cause immediate problems, let alone the security problems that it creates. There are people making poison pill public repos on things like GitHub. The anti-AI warfare is amazing. Anyhow, so we load this as a uniform for our input and output. Input texture is just a basic texture. Output texture is an EXR. Frequently, King Tag, frequently. So we need to decide how many per. We can just do that here. No upside down parkour run yet, Lunar. Okay, we'll do our loop in here for now. We'll just give it a fixed size as it comes in. We'll give it the width and we'll calculate how much each one has to do. Okay, so it's going to be a uniform we'll try to make it a uint, but it really just needs to be a uniform int. Binding to should just be a uniform integer. Nope. Non-opaque outside of a block. Why not? Oh. We'll probably use a vector for this. No, the shader for the floor is a flow. We're doing a flow map here. So you have just an image for the floor in chunks. Hey there, APOC. So I will just display images for the chunks. We could do a sliding shader. And hello, Bad Wolf. Welcome, folks. Welcome. We can do a sliding shader for the floor, but for the time being, what we're doing is fixed image blocks. Each of those blocks represents some part of the room, and there is a corresponding floor image for that creates the movable ground, like where objects can be. So a matched size image. This shader is going to convert that floor into a big float grid that is going to, or a big color grid that is going to be able to tell us this is how something can move to avoid walls. For the player and a lot of bullets and the like, you can just look at it and say, did it bump a wall in this movement? But for enemies, we don't want to have them bump against the wall and calculate where to go. So using this logic, what we're going to be able to do is create a series of vectors. Yeah, like a navigation mesh kind of thing. Where right now it's 1-to-1, but I could expand it out so that each navigation portion covers more pixels. Okay, so if we pass in the width and the height, we're going to be able to, from the globals, we'll get our local invocation set up here. We just want one across the board to be explicit. Again, we can iterate over this. We're not gonna. So in the example I showed, when the things are moving, we take an image file, an EXR, that is bigger than the screen, and that big grid says if you are at this position relative to your target, this is the vector that you use to move. So all of these are just saying, based on my position relative to this is where I move. We're going to combine that with the kind of the navigation data from the floor. Eventually, assuming we get that and it's still okay, we're going to have a corresponding texture that we'll use that is where all of these are. Kind of like a heat map of where the enemies are, where we can combine all three of those: the direction to the player, where the navigable floor says I should move, as well as where enemies are as a sort of flocking anti-gravitation, so they don't overlap with each other, because again, that contracting ring is 10,000 enemies. The enemy's ability to hurt the player is not active right now. Gameplay-wise, this is what we're doing. We are making modular weapons, so when the player gets upgrades, it's not this item levels up, it's we're changing the behavior of this item, and you are trying to build good stuff. If you're familiar with the game Noida, we're trying to be like that. So I can change the behavior of the projectiles, and we get our big hitch because Godot doesn't like to create that many objects at once. The code in general doesn't like to have to iterate over that many things at once in real time. But these are all still Godot sprites. Eventually we'll probably change them. Again, we might revisit stuff. So again, we have 10,000 things. Right now we're emitting 3 to the 5th bullets at once. Each of these bullets has chosen a target at random and is trying to move towards it, and simultaneously they are being pulled into orbit around the player. So that's why periodically you get sort of like a tidal pull showing up in the circle here. It's as their movement tries to pull out of the orbital circle. We should have impact soon. There's about 2,000 bullets. They live for about 10 seconds. The enemies will overwhelm them just by sheer numbers. And once they're close enough to the player, the projectiles don't have time to split before they're wiped out. So in the time of their existence, the bullets wiped out about 600 things. Collision is not perfect yet as a result, but that's over time we'll do better. Okay, we know the height and the width, so we can calculate out how many there are. We can modulate based on width as to which row we're in. Sorry, height based on which row we're in, and then modify off of width. We'll get our global invocation, which will be about the same thing as the collision shader. So we'll go here, and when we launch it, it's going to be 4464, which I believe currently, as far as work groups, is the most we're allowed to do before it explodes. Yeah, it's a big, complicated project. You can see based on the stream title, that's how many streams we've had of poking at this. I've been steadily doing more and more research and poking offline. But it's, it's let's all thrash around and learn more C#. We're learning Godot. We're learning shaders. It's fun for particular values of fun. But yeah, it's a lot to do. It's a huge bite as far as a first game developed for a single person. But it's what I want to do. Okay, we make our rendering device. We set up our uniforms, which won't be a storage buffer, and then we'll add them in. So the first thing is we need to create our shader. We need a lot of this. All right, we'll take you and you and you and you. Just copy you over into our flow generator. Lots of constants. We have our flow to center. We want all of these because we are going to be querying it over and over and setting those shaders. We are doing these as specific ones in case I need to add more for different flow generations. We shouldn't need one for the enemy presence, but we may end up doing that where we give this a texture and it gives us one back. We just need to be careful with memory management if we do that. We have these, and then our... We do need to get rid of these when we're done. I believe this one has its exit tree, maybe? Actually, it shouldn't need exit tree. It should be when it's just dead. Ah, okay. This one doesn't actually need to be part of the tree, but it is currently. Releasing the shader. Do we need to release uniforms explicitly? Forums using compute shaders. Use the stable version of the document. Iterating data buffers. Go render. Yep. Results. Buffers, pipelines, and uniform sets have to be freed. I'm not freeing that here. That's... We're releasing a buffer. We have an output buffer that we're not freeing. Well, that's going to cause problems. Actually make sure that we are. I think when we did this initially, free the shader last, just in case. I need to remember to do this kind of thing, because if we don't, it'll... Well, this one will cause a leak. Pipeline. And I think we free the uniform. Nope. Where do we free that? I believe that's in game start. We sync it. Get our results. Okay, we free the pipeline in the uniform set there. Okay. Gotta remind myself now and again. So here, it'll be underscore exit tree. Godot terms. There. I'm not familiar with Fairly, no. But yeah, I could see games taking forever to do. Okay, when we're here, we're going to make our shader. Hopping back and forth between this as far as creating everything. I need our collision shader script. Our flow. Sadly, this is another one that we need to fully specify. Yeah. Grab this and we'll mess with it. Services, flow generation. Flow generation, shaders. Is flow. We will eventually clean that up. Okay. File, make our shader. Not that. Okay, we have our shader now. We should be able to set uniforms directly into the shader from here, because that's not going to change. No, we will set the texture ones later. Device free it. World step done. Compute collisions. Okay. We are going to do all of this kind of thing. We won't be buffer updating, but we will create uniform sets, as well as a compute list, as well as this into the submit. That that is in our get, though? Here. Gonna get burnout? I mean, that happens periodically. I have a lot of folks helping me keep on it. Like I said, I find this kind of thing pretty fun. You mean the plot of the game? The general narrative? Is our output texture, and we have our input texture. Yes. You and clear all of that out for now. Floor flow pipeline. Dot. Can we do it as a buffer? Well, we'll start here. We don't buffer update for this. This is our I can type, totally. I mean, so the initial things that we did, or the initial stuff that we were doing on this channel, was a lot of gaming. And we latched onto the game Noida pretty early. Putting a buffer. Anyway, we latched onto Noida and we played so much of that. And one of the things that we started to add was the concept of a catbot. It was a replacement for a mechanic in the game, but it started to have its own life. And we just had continuous fun with that. Eventually, it expanded into a custom mod for the channel. Did that in Lua script. Grafted that into some of the exposed C code in Noida that they expose for sort of for modding purposes. And that worked for a bit in Twitch, and then we expanded to YouTube, and we had to add even more custom stuff to extract YouTube chat concepts and get them pulled in. And as it went along, sort of the story of the little catbot creatures grew and grew until you had the image of me that you see before you. And doing that whole process kind of revived my interest in doing my own game again. It's something that I've wanted to do. I think a lot of people that grew up gaming wanted to make their own game, and it's so daunting up front, and something that I've come to know as far as programming is a lot of learning, a lot of that kind of stuff is just doing it, is just starting it. And I mean, that's my advice to a lot of people. Like, how do I get into programming? How do I get into games? It's pick something and start. The era that I learned to program is so foreign to our current era as far as information that you have available to you. Like, I can just go onto YouTube and search like Unreal Engine or Unity or Game Maker or whatever you want to use, or just how to make a game, and there is viable advice out there on how to get started, what kind of resources you can use. Platforms like Godot are self-contained. Like, you don't need to know how to do C#. You don't need Visual Studio. It's there all packaged up for you to try out. Maybe you like it, maybe you don't like it. So we're going to add these to the pipeline. For profiting from this project, initial goal for the project, as far as like release, is Steam Early Access and roll from there. If that goes well and I can make it work, maybe mobile. But mobile is its own can of worms. Godot does let you compile for it, but given all the shader shenanigans I'm doing, that creates compatibility risks with smartphones. But that's the general goal, is get it onto Steam first. If it works on Steam, then kick off that into other platforms. We're not setting materials. Not setting materials, so it's different than that. Oh, to set. That's how I mess with it. Come on, AI summary, do your job. So it's an RD texture that it's creating. Hopefully we won't need to do that. Uniform type of binding, and we're going to add the texture RID. We might have to use the rendering device to get this set up, but yeah, I acknowledge you. Yeah. Cat chirping at me. Then we will create from texture. Using the output texture RID. Create the texture using the format. Do I have to do it that way? This is my first game project, yes. I've I've coded professionally before, not in C#, but I kind of like C#. If nothing else, it just reminded me of the coding language that I first formally learned. You know, setting aside things like BASIC, you know. So I find I have an affinity for it. Form sampler 2D's import texture. Then an image. So if we... Do I need to use it as a sampler? Well, we're going to find out. Define it, bind it in C#. Okay. I'm going to add an item. So this implies to me that this is older stuff. And this is not uncommon when you try to do like AI summary or even like... this is part of the learning to code is which online resources are accurate. Godot went through some big changes moving over to its more recent like 4 version. And there's a lot of old 3 version stuff still out there. And for some types of object, it's completely different. Laura, who popped in over on the Twitch side, or I'm sorry, on the tall format side, is making a BattleTech style game. You know, simple stuff, or at least not like, you know, fully 3D BattleTech game, but they're doing their own first game project. And when they were setting up a grid in that, all those tutorials caused some real issues because the tile map layer concept in Godot 3 is completely different in Godot 4. Like, incompatibly different. Okay, so we're going to add our texture RID to it. It doesn't like something about the GLSL right now. Which line don't you like? It doesn't like line 9, which is right about here. Why do you not like that? Binding requires a block, a sampler. Yeah. It doesn't like the way I'm setting up the uniforming code there. How are we setting that up? Once more. Google, why are you doing this? Oh my God. I don't need search suggestions autofilling at the bottom of my web page. Ah, okay. Pass in a uniform buffer. Okay, we can do a buffer for that. And we could do a structure for it. And since we're just passing in integers in a particular order, we should be okay. Okay. Who's watching from Twitch? A couple of people popped in. We don't get a lot of chatter because of, it's coding. Not that window, this window. Not that window. This window. Yeah, we got a few people watching over on Twitch. Key is frequently on Twitch. Okay, so we have a struct. That above our layout. Okay. Image params. Should just be able to do uint. We'll need to define that elsewhere, and we'll make this a buffer. Hello, Sky. I do. Yes. Hey, Mohammed. Welcome, welcome. I'm giving a cat a hug, because otherwise he'll get right up in my face. Okay, we need to get our buffer loaded over here. Here we go. No, it would be this style. We'll do instead of this, so that'll be binding 2, and it's an image params type. So we will set it up as a buffer using standard 430, so we should be able to set it up in the same way. Sometimes I have limited typing ability because there is cat in the way. This guy is currently leaning against my mouse arm here. Not sure. You might be able to hear him while I'm talking, or at the end of me talking. Let's find out. Maybe at the tail end, yeah. Because he is. Okay, so we pass in image params. Here. So we need to define that in our flow generator interface. Is in a similar fashion to our shader collider interface. Not that one. And we didn't do this as a... Oh, that's right. This is a collision manager. Where did we put that? Not that. Shader collider data. Okay, go to definition. All right, public structure. This is one of the things that can trip you up with shaders, is having to carefully block out the data as far as where it goes. Vectors in particular can trip you up because it vectors are always stored as if they were a vector 4 in size. So after the 2 floats that make up this vector 2, there's 2 floats worth of space after it that you need to account for not existing. And that's why these pad values are here. Because this block of 4 will show up properly. This block of 4 will show up properly. And then this block of 4 shows up. If you put them in the wrong order or you don't account for these dead zones, then the result on the shader side will be off address. Your data values will be wrong. Like in this case, you get gibberish inside of floats. Okay, so we're going to define a public struct here. We'll put that in our... That's implementation specific, so we'll put it here. That's both by necessity and by interest. I mean, shaders are... They're absolutely landmines. It's easy to do them wrong, but it's also so much power as far as what you can do. We're going to make this specific. Must type slowly, cannot disturb cat. The one sitting on my lap currently is Sky. He is my currently oldest cat. He is in competition for the largest of them. The other one is... I think, yeah, the one on the pillow in the lower right of the cat cam currently is the other one. It's kind of hard to tell. Sky is very fluffy and Mason is very short-haired and lean. But they're very comparable in size. Sky was previously definitively my most mischievous cat, and I still think he is. The youngest cat, Molly, competes in that territory now, though. She is a nuisance. But Sky will wreck stuff if you try to ignore him, especially when he wants something. He will look at you and chirp. If he wants something and you've been ignoring him, he will definitely do this. If you make eye contact with him, then he will do something, like he'll shove something off a shelf or similar to say, hey, you're ignoring me, look what I did. I have 6 cats. Let's see how many we can spot aside from Sky. We have 2 on camera on the... Let's see, you are looking in widescreen format, so camera on the left. There's 2 there. We have 1 up in the cat tree, that's Molly. Sammy and Mason left to right on the bed there. Then top center is Ember. She is the second oldest and by far the smallest. Sherbet is over by the door in a cat carrier. He likes to hide in the cat carrier when he doesn't have to be in the cat carrier. I mentioned him. He's hopped out. Let's see if we can spot where he goes. He is heading at least past the food dishes. Okay, yep. He's getting a drink. That's Sherbet. He's Mason's brother. He is, he's about the size of Sammy. Sammy's stockier than him, but he's about the same size. And his fur is very mottled compared to Mason. He's my most skittish cat as well. He likes to get back scratches, but only periodically, and you better not make sudden movements. Hello, Sky. So we have a uint width. But as might be apparent, King Tag, a big part of my process is stream of consciousness. I will often just say repeatedly what I'm thinking about and what I'm trying to do in order to... It's kind of rubber duck programming. Is if I hear myself say it, sometimes I will notice something that's wrong. Okay, we will set that in... Show this. I have been told I am the male equivalent of a crazy cat lady. Image, bounds, create a floor flow. Okay. If we have a floor texture, this is where we want to be. We're still going to have to do this correctly. You aren't able to see it on the play area camera, but like I have a pair of litter robots, the good kind. You know, not the evil Timu we have litter robot at home guillotines. Okay, we're creating pipeline. This one takes our floor texture, I believe. Yes. Let's do floor image. Can we do that? Get RID. Actually, we're heading into our second break and running past our... We have run past our first, so I will be right back. And we're back. Hey there, James. Welcome. Okay, so we're passing in the back at it. Okay. We're passing in the input texture here. We have created the floor flow image. Definitely will, King Tag, and thanks for swinging through. A goal is to start posting like progress videos. I really should already be doing that. Hopefully we will be near a point where the progress video won't be esoteric stuff about, hey, I finished a shader, you can't see it happening, but it's really cool. Updating a buffer here, we're saying floor get our ID. Flow uniform set. Input texture uniform and output texture uniform. And our floor flow shader. That, and that, and that, and that. Create that. Rendering device is going to be our floor flow pipeline. Floor flow uniform set. We break that into 1024 pieces and submit it. Then we are going to sync it back. Which we will have to extract. We'll have to extract that. Okay. All back. How were we doing this over here? Be one of our on steps, and it will be on game start step. It's buffer get data. So rendering device sync. And then we're going to do a get data. Hello, Molly. Are you going to step on the soundboard? Oh, wow, you did not. Good girl. Molly has come to sit with me. Yes, I acknowledge you still, Sky. I do. Molly is my clumsiest and statickiest cat. She blunders into everything she moves past, and just brushing her fur lightly will cause an arc in this dry weather. Okay, so we're over here. Say rendering device dot sync. Not get. Not a buffer is the trick. Do a quick look here. Fine, a uniform, yes. Yes. Data back. Okay, well, we'll do this entirely differently. Cough, cough. Okay, we're not going to do it that way. Instead, we're going to set them up as buffers. Those buffers will be the individual objects. And I'm going to pass them as individual buffers because I don't want to deal with size constraints on them. Okay. Fine, fine. Okay, so we're going to set up the buffers. We're going to set their sizes, or we're going to feed them data based on the size. Oh. Microsoft is dropping Microsoft wasn't king of reliability before, but at least they could be trusted to not mess up as badly as they are right now. So the whole principle of move fast and break things is that you follow it up with, and then you fix those things and do it in a iterative loop. They have been breaking things so hard in the effort to cram Copilot and related systems in where they are not useful, don't belong, or are huge privacy concerns. You know, I'm looking at you, Windows Recall. Windows Recall that is totally not going to be used for AI training data. Windows Recall. And it's just broken thing after broken thing. And then they come out and proudly declare that 30% of their code base is being generated by AI. And I bet it's the broken part. Just Just stop it. Okay, we are going to make the buffers initially. We need a max size, though. Do we? I feel like if we don't, there'll be a problem, but... I don't want just a uniform because I need to get it back. Oh, but I can do it as a uniform passed in initially. And the output is going to be the size of that as an input. As when I create the buffer. Okay. Okay. That'll totally work. Input params in that. This should be an input buffer. This can be an input uniform. Because I never need to get it back out. I just need to set it. Creating the uniform, and we're passing it in here. And then on the other side, in the GLSL, we're saying that it is an image 2D, it is the floor texture. Then, in place of this one, we're going to do this as a buffer. Is a write-only buffer, and it's going to have an image 2D. Okay. Does it like that? It does not. Doesn't like that. We can't pass in to a buffer that. Actually, let's verify. Okay, once more into the code searches here. Need an output texture. Form image 2D. Yes, yes. Yeah, that won't help. I'm looking up documentation once more. Looking for, not what I'm looking for. Let's share it that way. These things are never what people say they are. We're looking for a way to get a texture out of a compute shader. I don't want to use it in other shaders as an immediate material. I want to extract it. Yes. Okay, that should give me a texture if I do it that way. Okay, so I tell... Maybe? Okay. So it does need to be an actual uniform to pass it in. So it needs to be this. I will pass in one image params to this one. Okay, so what we're going to do here is we need to set up the uniforms and we set them in. There's our output texture. Yep, we're going to add the RID in that way. So in our flow generator, we are going to add the RID for the floor and the flow here. We also need to set up a buffer for the params. Param bytes is that big. Then when we do our world step, we compute our collisions and we update the buffer with those values. This is also where we're going to set our uniforms here. So we will set the uniform values here and we will send it out. And then we are going to get it back as an output texture and return that. Okay. So I need to create the buffer like we do in Ready. Okay, so we need our params buffer. LoRa flow input params buffer is equal to rendering device dot create buffer. Not create buffer. Storage buffer create. We're just going to create it because it is a known commodity here. As far as what it's going to have in it, but we're going to be updating it each time. This is a byte array. New byte array, which contains size or Marshall dot size of memory Marshall. Nope. Let's find it. Marshall dot size of. Not shader collider data. It is that. Create, which needs a uint. data sizing dot length. RAM data for sizing. Okay, so in this scenario, we don't really care what's in it right now. We're gonna update it later. Create it, we sync it, then our sure 2D RD. Don't actually want that. We're gonna see what this results in. We're also gonna add it's not really a radius. Call it search range. So then in here, this is a series of uints. It doesn't matter that there's a gap after it. Or it should not matter, because we know what this is when we're storing it. We could just make it a uniform, but if I can make it a buffer, I'll make it a buffer. Down here, when we are creating it, before we set the params uniform, input start width. I actually need to define that. Why would I need to define that? Well, we do. Why would you have protected stuff on a... If you have to have access parameters on a struct, you've got an object, not a struct. Edge params dot height is equal to floor texture dot get height. doesn't this ever show up? Never calling flow in bounds because why? You never call it and everything works, we're okay, so. Okay. Search range there so that when we are calling into it, setting it up, we don't need to Marshall dot do a Marshall cast here somewhere. Data on collider change, we update collider data, cast that as bytes, and then we edit the data. Okay, we cast from that to that, from the struct to byte. And that will get us a span, which we will use as the array that we pass in. Memory Marshall. Passed from this byte Test image params. Needs a span. Okay. That wants data as an array of bytes. Okay, so we are converting. We are creating a span as an array. This is as an array of bytes. We're passing in a single one of these, which should be an array of bytes. Okay. Texture uniform, input texture uniform. We need to do another uniform set here. Storage buffer, its binding is 2. And we are going to add the buffer when we do our compute. When we do the add ID, we do the buffer that we created. But we don't do the storage buffer create here. We're going to do a storage buffer update when we do this. So we do this buffer, offset of 0. The size in bytes and the data. Okay, so we've updated that. We need to create it elsewhere. We can create the bytes ID elsewhere. Protected byte array. So then in this one, there is a point at which we set that. That's where we are creating the new bytes. So need to set this up in our constructor. Size of flow date. Okay. We pass in image params. How do we do that? Array is equal to. These are all the 0th value. Yeah, when we do the initial cast, we do it that way. The bytes we treat as a span later. Okay, no, we set up the bytes. We know what that is. How are we doing that? We do the bytes up front, then later when we are extracting it, so on game start step, we cast it to a span. So we have our bytes in existence. We cast those into a span and we can mess with them. Okay. So up here, we have span of flow image params is equal to past byte to flow image params. Our bytes here. So this is nothing. This is all empty. But we have a span now, and now we can say this. Actually, copy this one. And we can pass in the param byte. So what we've done is this flow image params is actually the same memory as param bytes. We're saying this space in memory this thing overlaps this space in memory, but it's whatever type we want it to be. So now when I mess with image params here, which there's only the one of them, it alters the bytes. And that's when I'm retrieving it. Do a buffer update, we add the ID to our uniform. We are going to free the uniform set each start step, I believe. Yeah, the pipeline and the uniform set are freed each time. So then we're going to get our output value by having a (2D_RD) We're going to try just with this. And we're going to create an image that matches that. Okay, to do this, we need to do we're going to force this call when we create it. We get a floor flow. And we're just going to pass in X. Create the floor flow. We're going to get the texture from the catalog. we're going to make an empty texture for this. For testing purposes. Oh, there's a trick to this. Go quickly. Image texture dot create from image, but do we actually need to do that? Oh boy. Made it null around the same time we get it. Just below, make the file. 10 by 10. Our folder. It is nothing. Okay. Then if in the shader we just do something terrible here, which is zero, I is less than 10, I plus plus. Actually, width. J height. Blow texture. We need the set for that. We need the set for that. Compute. Image store, out image, position. Vector 2i, right? I vec2. J. And this is going to be a vec4 is equal to width divided by I divided by height 0, 1. Hey, do you hate that or not, Godot? Okay. We will run it. End that, and then we go over here. It's changed. Let's run it on the Godot side. feel like there might be an error. Output error. Not altered in any way. Base flow generator. That, and this. Dated, open it. Okay, did not change. Let's go into our create. Let's actually show the game screen. Sorry, folks. Sure, 2D, RD. Equal to floor flow dot get RID. Image store in the script. We've got the rendering device. Rendering device. Those are all not useful to me. Using the rendering device to create textures, I thought. Using image. I think that would be necessary, but finding but we want to read the data back to the CPU is the problem. extra usage can copy from. Make a RD texture format. We're going to create the texture. We're going to pass that. Got used to it, Laura? I have no point in time key as far as when I plan to have it ready. Once we're done with the skeletal stuff here, which I've been saying for a long time now, but once we've got the bones of it done, then it's a matter of content, and I can start to consider kind of early access style stuff. But right now, with the like rendering and collision frequently in flux, I can't get to actual content. Like this room thing was not planned for. Find it. It's going to be an image 2D still. That's fine. That's fine. But we need to create it in this fashion. Okay. We need a texture format. We set its width and height and then its actual format. Okay. So here we're not doing create empty. RD texture format. It's equal to that texture format. Width is equal to floor width. Say uint height as a uint. Equal to rendering device data format. Okay. I think it's 16. Can I find that? GBA 16 B16 A16. I think it's that. What is it? Usage bits first. device. And right now we're looking at can update, storage, and can copy. Update bit or can copy. Storage and can copy from. Okay, so that's bits are equal to this or this or this. Then we are going to rendering device texture create. Texture format, comma. RD texture view. And that gives us our is our output texture is equal to then when we are retrieving it, rendering device texture get data as image. Texture get data. Texture, comma, 0. Data as image. Doesn't have that. Image dot create Hey there, Knight. Yes, it is laying on a squishable. That is a favored spot for a couple of them. The black cat in particular really likes the squishable pillow. Okay, let's... What can we do with this? Image.create from data. Right? Yeah. Data. So now we need our width, floor height. Format dot BAH output bytes. Game is moving along. Oh. False. We are still deep in the skeleton of it. We keep having to double back there. But, you know. Build. And was just updated. Check the file. Nothing. All right, let's check it on the Godot side. Nothing wrong in the shader. Hey, Samarium. Doing well. Okay, we have 5 debugger errors. Wow, no. Okay. 266. Here. Floor flow uniform set. Well, if it's dead by then, that's kind of weird. get rid of that. Never supplied for set 0. Zero, 1, and 2, right? In 2. Input, output, and flow image params. Image params uniform. Okay, that. Go back here, run it again. We keep fiddling with real technical stuff here. Uh, 259, we missed something here. Shader set 0. Image params, which we add to the buffer. It is set 0. To here. RID 0, it didn't generate anything. Why? The list of uniforms, the shader, and the shader set, which is 0. That's right, isn't it? Compute collisions. Add it, we add it. There is some element upstream from this because it says set 0 was never added. So there's a problem with the uniforms, I suspect. We get a uniform. We add floor images RID. Yep. Also have a uniform there. past that, if we look at image params, we should have a single one. So now we're going to set the params. Low image params. One has its values. We're also going to look at our param data bytes. So we have our 10, and our 5. So our buffer we didn't make a buffer. There is our problem. We need to make sure that the buffer gets created. Storage buffer create. Should be in our constructor that we're doing that. But we don't. But we don't. Don't we? We don't. We don't. But we're going to do it largely the same way as buffer update. I want to get this portion wrapped up before we close out today. Bytes data. Okay, we're going to run it on the Godot side since it can spot the errors that we're dealing with. We're down to 4 errors. Same thing. $263. But perhaps we will not. Okay, we have a buffer here, so that's good. We got a texture uniform. Updating the buffer update content. Params uniform exists. Flow uniform set now exists. No, it doesn't. Since we have that, we can't run the shader. So there's something wrong with these. We never get our uniform set data, so it's never going to work in that sense. And so we can't free it when we're done with it. Which means we can't get the data, so we've still got a flaw going on in these uniforms. Okay, no. We need floor flow. We're going to pass in the floor flow RID when we pass in this one. Okay, to that, run it again. Here, still the same problem. Which one? Oh, binding 0, expected image got texture. For binding 0. I've been barking up the wrong tree with this whole pattern here. Nope. $247. It's expecting an image. Did not get that. was expecting an image. It got a texture. Is that the shader was expecting an image? Look at the shader. We have it set up to be image 2D. Maybe it has to be like a sampler. Might need some research between now and the next thing here. We've got an image. Now this one's a texture, but that's not the one that it doesn't like. It's for binding 0. Recreate that easily enough. So it doesn't like this. Expected image got texture. So the thing that it's receiving, can we... Does it need sampler? Oof. I'm going to have to try to find some references here, folks. Thrashing a bit, and that's going to bog progress down even more than if there were just a regular error. I need to figure out how to structure this properly so it will accept what I'm passing in. Because we've got images on one part, and then we have a very particular way of defining a texture in here that it will accept it. So we need how we're supposed to define this in order to actually let it come in. Index, meta, script, string, yeah. We're going to need to figure out how to actually do that. So we'll wrap up there for now. But some progress made. We're getting there. We're not done with the shader yet, which means that there's some distance to go. But we have the compute, like, prepped. We have the general outline of the algorithm ready. We'll see how it goes once we get to there. Next coding stream should be on Friday. But with that said, folks, hope you had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those buttons are generally good. I'd appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means as well as some off-platform options that are available in the LinkTree. That is in my video descriptions in my bio. With all that said, I hope the rest of your day is good, and I will see you next time.